So I have a buddy of mine. He has a 3D printing company, and the stuff. I remember when 3D printers first came out. I got a little chest set 3D, but the stuff that they can do now is amazing. So, I mean, I thought about, you could print a tool in space, but you're talking about printing an entire satellite.
So if you think about something that you put in space, it has to go through this launch. And this launch has 3 G's worth of force that are upon it. And it takes 8 minutes to get there, and there's a lot of vibration. And that drives the loads for whatever this satellite looks like. It's got to be really robust. But once you get the satellite into space, now there's no loads on the satellite. It's in zero gravity. So all that load-bearing structure is done just for the launch. So imagine what a structure would look like now if you built it in space where it didn't have to go through that launch sequence. It would be much lighter. It would be probably a completely different configuration. So that would be one way that you could build a satellite. Here's the thing that's really interesting, though. Let's say that you are going on a trip to Mars. So if you think of all the logistics of all the things that you need to take with you on this 2-year trip or 3-year trip to Mars and back, it just becomes a huge problem of logistics. How am I going to have all the right tools? How am I going to have all the right spares? So where 3D printing comes into play is you don't actually have to have all those pieces with you when you launch to go to Mars. What you have is a 3D printer, you have the material that you want to print the stuff out of, and you have all the software and code for what you need to print. And now as you go along, if a component breaks, then you just 3D print a new one, and who knows, maybe you 3D print the tool that you need to fix whatever it is, and it drastically reduces your logistics problem for trying to go on long-term human space exploration.
Wow, amazing.
And just to add to that, on the space station right now, we have a complete set of snap-on tools, English and metric. Probably weighs 300-400 pounds. Plus, so you can see if you can offload those things and just make what you need as you go. It's a huge improvement in what you have to send to Mars.
And you said, so 1 pound that you send up, how many pounds of fuel?
It means 9 pounds of fuel for every pound you want to put in space.
300 pounds of tools. I mean, do the math. I'm going to try and do it. I'm an engineer. 2,700 pounds of fuel that you don't. Right. Wow. I mean, so everything like that, you could. That's amazing.
And let's take it one step further. So the further you get into space, that 9 pounds becomes even bigger. So for example, if you wanted to take a pound from Earth and put it on the lunar surface and then bring it back to Earth again, then you need to launch 45 pounds from Earth to make that happen.
Tell me more.
45 pounds. So if I want to put, let's say I want to put a habitat on the moon.
Okay.
So for every pound that I want to put on the moon for that habitat, I got to launch 45 pounds with all of these supplies that Carl was talking about as well. If I can 3D print everything, now I don't have to have such a robust structure that had to go through the launch from Earth, right? I mean, you're sitting on the moon, the gravity's less, the structure can be less, and so 3D printing in space helps solve the logistics problem that we face of having to pay the penalty for weight of getting it out of the Earth's gravity well.
Amazing.